Example number 9, write in terms of log x and log y. So our job here is to do the opposite of what we just did. Kind of work backwards. Things are combined, and the idea is now we want to split them up. And the part that's not mentioned here, but it's not, is that we don't want any exponents. So we need it to be exactly log x and exactly log y, or log z, or whatever the letters happen to be. So let's do that here. We want to split this up. Now I know when things are being multiplied, the log law was that they must have been added before. And anything that's being divided means it must have been subtracted. So this is really a log x plus a log y, because that would have allowed me to multiply them together, and it must have been a subtraction of a log z, because that's what would force that into a division when we combine them. And that's all there is to it. So that's what we're looking for. Obviously, this one is really straightforward, and they will get a little more complicated, but for now, that's kind of how that works. So this one would be log 1 minus log of x squared. Now, this right here, I mean, you can think of this as a 10, but it almost doesn't even matter. So let's think of this as a 10 for a minute. This is 10 to the what would have got me 1. And we've mentioned this already several times, is that this must have been a 0, 10 to the 0. So really, this just becomes 0. And then for this one, the x squared minus, we can bring the 2 down and write it as log of x. So 2 times log of x. And then, of course, you don't actually need the 0. You can go negative 2 log of x. So I split this up to a 1 minus x squared. And then at log of, really, log base, it doesn't even matter. This is kind of a little this, where if a can be any positive number, that will always be 0. So that's kind of a little hint if you ever wanted to write that down. But 10 to the 0 got me 1, so this was just a 0, and this 2 could come down. So let's try C. So there is an x cubed. It's not being added with anything, but it is positive because it is up above. And then these are on the bottom, so we must subtract them. Log of z. Now this is a z square root. Now square root means power of a half, so I'm going to write that down as the power of a half. And I'm almost done here. I just don't want these exponents, so I'll bring this 3 down, make it a times. 3 times log of x minus, there's nothing needed for this one, minus a half log of z. Okay, so I'll just zoom out here. We're going to do the next ones, but if you want to kind of take a look at those, you can. Otherwise, they are already posted, and it's probably a little bit neater as well. Okay, let's take a look at the next one. These are all, they're all on top. They're all on the numerator. So they must have all been adding. So I have a log of 1,000 plus a log of an x plus a log of a y. And the reason this one's here is because this right there, the log of 1,000, that's actually a number. And it's one that people often forget. So remember, there's a 10 there. So 10 to the what gets me 1,000. That's what this is asking. I'll write this down here. 10 to the what got me 1,000. In which case that was 3. So this is a 3 plus log of x plus log of y. And again, I like to put brackets around the x and y just to emphasize that it's log of all of this stuff. So the tricky part there would just have been the 3. Okay, so for this one, I can split this up. These are all on the numerator. They're all being timed, so I can leave them all on the, all as positive. Now this is log base x, so all of these will have to be a log base x. Now for this log base x of 100, That's fine. Now this one right here, the 2 can come down because remember I don't want any exponents. And then log base x of y. And what's really interesting about this one is that there are a couple of things that we can do. Remember how I said here log base 10 of 10. 10 to the what gets me 10? Well, just 1. That's just 1. Log of 17, 17. So 17 to the what gets me 17? Well, 17 to the power of 1 does. And that's when we wrote log base a of a is always 1. So this is just a 1, which means this, x to the what, gets me x, well, just a 1. So this is actually a 2 times a 1. Now you could write this, it's not necessary, but you could use a change of base if you wanted to write this log of y over log of x. Oh, actually, no, I do need to, because I want to write them as it said here, wanted in log x and log y, where there was a base 10. And right now, these are base x. This is a base x, so I need to split these up. Now they're both base 10. And same thing with this side, log of 100 over log of x. Which you think that would be it. So we separated that. This just canceled. We separated that. But log of 100, that's also a number. Because remember, this is a 10. So this is a 10 to the what gets me 100. Well, that would have been a 2. So this is really a 2 over log of x plus, there's that 2 in the middle, plus log of y over log of x. And you can leave it like that. I'm fine with that. Though if you look in the notes, you'll see that this left term and this right term I've combined to be 2 plus log y all over log of x. So if you wanted to write that, you could, but it's not necessary. So f. Well, I'll leave this actually here in case you want to copy anything down. Now for f, this is base 10, so I don't have to worry about anything. So I've got log of 1,000, and it's timesing, so these are all being plus. Plus, well, actually, you know what? Let's maybe separate this. I'm just thinking this right now. I've got a log of 1,000. There's an x. There's a square root of y all over a square root of z. So that's the first step, because you could have combined these. I can't remember what grade we do that in, but for radicals, you can combine these under one radical. So in the same way, if I have them all under one radical, I can split them up into 2 radicals. And now that I have that like that, I can go log of 1,000. These are all in the numerator, so they'll be plus. So log of x plus log of y. Now it is a square root, so I'm going to put a half. And that's on the bottom, so I'll do a minus log of z, and again I'll put a half because that's what a square root symbol is. Now this, I think, is just a 3, because this asks 10 to the what gets me 1,000, and the answer is 3. Plus this is a log of x, plus this is a half log of y, minus this is a half log of z. All right, so that's all of the questions. I'll zoom out so you can see all 6 of them. That's what we just did. There's a lot going on in this, but I just want to put an emphasis on what we're going to be doing next, which is solving. That to me is the most important part. Yes, you're going to use some of these log laws when we solve, definitely, but the emphasis should be on solving these things versus just kind of manipulating them a little bit. So yes, this is still important. You need to know this stuff, but I want to make sure that I emphasize what's to come, as I think it's actually more important.